I'm recording. All right, so start off with your free body diagram, just down here at the bottom. G, F. This may seem a little redundant. What did I do? Did I add too many? I did. My C is out of place, that's why. Let me finish this, then I'll talk. C, D. I don't really care, honestly, for this free body diagram, how detailed the inside is. I'm more concerned about the external forces. So, external forces. Let's go to a different color. All right. I'm going to go with blue. So my normal forces, those that are pulling down at the joints, I have a 3. K is 1,000. So I'm just going to go ahead and say 3,000, and they're not giving me units here, are they? So we'll just say 3,000 pounds or something like that. Going down, 3 at G, I got another 3,000, let's say pounds, going down. And at F, I have 3,000 pounds going down. So I generally, in my free body diagram, start by identifying those normal forces, those things that are acting on the truss. Okay? Once I've done that, and I'll go to a different color, I'll go green, then I think about what is the reaction? What's going to happen at my joints, my pinned and rolled connections, the walls, where this truss is connected. So that would be here at my point E and here at point A. So I have a roller at point E and I have a pin at point A. So I know, okay, because this is true for all rigid members that are being supported, that if I have a roll, all right, it's going to resist in one dimension, up and down. So I'm going to have a reaction force at E in the Y direction. I'm assuming, which I think is a fair assumption, that it's going to point up. I mean, I can look at these forces, these normal forces pointing down, and say, yeah, it's probably going to point up. But there will not be any X forces at this roll joint because it's allowed to roll left and right. So there's no reaction in left and right. It's like a little wheel. When I go over to point A, there will be also a reaction at point A in the Y, and it will also, more than likely, I'm going to guess, point up. Pretty reasonable assumption, right? Because everything else is pointing down. But this one, since it's a pin, will also provide an X direction force. Okay? Now, I'm going to write that in as a reaction at A in the X direction. Now, I don't know which way it's going to go. Is it going to go left? Is it going to go right? I'm just going to guess at first and say in. And then if my math shows me, from my positives and negatives, that I need to flip that arrow, then I can do that later. For now, I'm just going to point in. So this is my free body diagram set up. Now I can move on to my math, which I don't have a lot of room for, but whatever. Okay. I want to solve first for REY. I want to know how much that roller joint is pushing up. I want to know how much that's pushing up. Okay? To find that, we'll go magenta, like all the different colors. To find that, maybe I'll do my math down here. I'm going to do the sum of my moments need to equal 0. Okay? So let's sum or add together all of our twisting forces. Let's start with all of the ones going in the clockwise direction. I just drew that arrow to show you the clockwise direction. So rotating around point A. That would be just like as if I took the roller joint off of E and kicked it out. Like kicked the wall down. And then this whole truss started to tip and rotate around A. What are all the forces that are pushing on it? Well, I've got this one, 3,000. It's pointing down, so it's negative. And it is 20 feet. Look, I'm looking at the truss up here in the drawing. It's 20 feet away from the pivot point. So I got to multiply that, because it's 11. Plus, I have another 3,000 sitting out there. Okay, maybe it's another air conditioner or a satellite dish or something. It's 3,000 pounds though. And how far is that away, from the pivot? It's another 20 feet. Absolute distance would be 40 then, because you got to add both those 20s, because it's how far it is away from the rotating point. So that's 40. Plus another 3,000. Maybe that's maybe somebody parked their car on the roof. That one is 60 feet away from the pivot point. Okay? Notice how they're all negative because they're all pointing down. In the end, all these have to equal 0, but there's one I'm missing, and that is REY. That's the one that's going counterclockwise, going the other way. REY is the only other one pushing up to prevent that wall from rotating. It's the only one. It's the only thing stopping the wall from rotating. Okay? So that's a force. Let's call it REY. But see, that force is a certain amount of distance away from the pivot point. How far? I don't know, let's add it up. 20, 40, 60, 80. That's how far. It's 80 feet away. So if you look at all that equation I just wrote, there's only one unknown, REY. So that is very simple math to solve for the value of REY. Very simple. There's a lot of numbers there. Can someone solve for REY so I don't have to mess up my... I don't have a lot of room. I'm afraid if I start scribbling numbers on this, I'm gonna start making a big mess. So I'm going to pause for a second, and somebody's going to give me what REY is, because I'm going to assume that everybody knows how to move REY times 80 to the other side and divide by the amount. So we should get something. Let's see, 6,000 plus 12,000 plus 18. 6, 12, and 18. 36. Does anybody have an answer yet?
4,500.
Thank you. Okay, assuming that's right, REY is going to push up at 4,500 right there. Now, if I look at my free body diagram, which I know, is it gets messy. Part of it is because I'm on an iPad with not a lot of room to draw. But if you look, the point I'm at now is I've summed the forces of my moments to equal 0. So all my twisting forces have been solved. Now I want to sum the forces in my y to equal 0. Okay? Yes, question?
You said you got something different.
Did you get a different number than 4,500? What'd you get?
You got 2,475.
So we got another number. 2,000 what?
475.
Alright, looks like I got to do my math here. Somebody, I got two numbers. I guess I got to check. Alright, guys. Who did it? 6,000. Alright, so 3,000 times 20.
Just do 3,000 times 120.
3,000 times 20 is 60,000. Plus 60,000, 180,000, and it's 4,500. Did you guys all get 4,500 at home?
Yes.
Okay, yeah, I got 4,500 too. What are you guys doing up there? Alright, I got 4,500. I can check your numbers here just in a minute. I got 4,500. Okay. That's okay. And I think that's probably where the biggest problem is with these truss problems, is making simple mistakes in these long algebraic operations. Okay, do me a favor, go with the 4,500 and then I'll check what you did with that previous one. Because, look, when I sum the forces in my y, literally look at all the y forces that we have. And I'm going to highlight them. I have, oh, that's erase. I don't want to do that. I have a y force here. I have a y force there. I have a y force there. I have a y force there. And I have a y force here. So when you do that, I want you to notice that I have only one of those is unknown. I have 3 of them that are pointing down and 2 of them that are pointing up. Obviously, I have to add them all together and make them equal to 0. And there's only one of them that I don't know. RAY. So if I do, I'll try to do this off the corner here. If I do negative 3,000 plus negative 3,000 plus negative 3,000, I know it's negative 9,000, but plus 4,500 plus RAY equals 0. I mean, now I can simplify that. You should be able to see it. Negative 9,000 plus 4,500, or I'm sorry, yeah, 4,500. 4,500 equals 0. So what is, I'm sorry, equals, oh my bad. Did I just write that wrong? I did. Negative 9,000 plus 4,500 plus RAY equals 0. So what does RAY have to be in order for that to equal 0? What does RAY have to be? If I'm pushing down 9,000 pounds, and one side's pushing up 4,500, what does the other side have to push up? Common sense, 4,500 pounds. So RAY equals 4,500. That's it. So RAY is 4,500. And then you sum the forces in the X, but that's easy. There's no X forces. There's none of them. I can't even highlight them because they're not there. Look, I can highlight this one, but there's nothing there. Okay? Questions? All right, I don't think we're going to do this first way. I think we'll do it next time because I think we just need to see the repetition. Unless you guys want to do it now. What do you guys want to do? You guys want to work on your bridge or do this one?
Bridge.
What do you guys want
It's
to do?
your call, Mr. Guys.
What do you guys want to do?
Bridge.
I know. All right, we'll work on the bridge. I'm okay with that. As long as you guys, honestly, as long as when we get through this, you guys are good with these calculations, that's fine. I'm going to stop the video. I will post this up